Hi friends, in this section I am talking about algorithm for deletion operation performed on a singly linked list. Okay, first of all, here is a diagram for structure of a singly linked list. Such a list is implemented by each item having a link to the next item. Okay, here we can see that head point to the first node by using address, and each node having a link by consists of addresses to next node. Okay, we can go through the different types of the operations that are used for deletion of a node from the list. First one is deleting from the top of the list. Second one is deleting from the end of the list, and the third one is deleting from the middle of the list. Okay, moving to the first operation, that is deleting from the top of the list. Here we can see that an algorithm is used for deleting from the top of the list. On step 1 we can see that if start equals to null, write underflow. That is, head is pointed to null and there have not any node in the list. So go to step 5, that is exit. Step 2 we can see that set pointer equals to start. Here pointer is a temporary variable used to store the starting address. On step 3 we can see that set start equals to start next. That means store the next part of the first node to header part. Then on the step 4 we want to delete the first node by freeing the temporary variable. Here we use pointer as a temporary variable, so delete the pointer variable by free pointer and exit. On this diagram we can see that pointer variable is deleted by free pointer, so head is pointed to the second node of the list, that is first node is deleted from the list. Here is the simple example for that. We have 4 nodes with different data values such as J, A, V and A. So that we want to delete first node from the list. For that, copy the address of the first node and store in a temporary variable. Then move the head to the second node of the linked list and disconnect the connection of first node to second node by deleting temporary variable. Then free the memory occupied by first node, that is J is deleted. Okay, next we can go through the second operation, that is deleting from the end of the list. On step 1 we can see that if start equals to null, write underflow. This is already discussed in the previous sections that head is pointed to null and there have not any node in the list. So go to step 8, that is exit. Else set pointer equals to start. Here pointer is a temporary variable that is used to store the starting address. On step 3, repeat step 4 and 5 while pointer next node equals to null. Here, by the pointer variable can able to traverse through the list and get the node having next part equals to null, that is last node in the list. Here the pointer 1 is a second pointer variable that is pointed to the second last node of the list. On step 6, we can say that set pointer next equals to null. That is, we just need to make the pointer 1 pointed to the null, and on step 7 we can see that free pointer, that is last node of the list that is pointed by a pointer will become free. In this diagram we can see that pointer 1 is a pointer variable that is pointed to the second last node in the list, and this pointer variable is used to pointed to the last node in the list. For disconnect the connection between the second last and last node by setting the next part of the second last node by null value, and delete the last node by free pointer. Here is the simple example for the deletion operation performed on the end of the list. Here we want to delete the last node which have data A. For that, disconnect the connection between the second last and last node by setting the next part of the second last node, that is V, with null value. Then by the help of the pointer variable that is pointed to the last node in the list, we can delete the last node by free this pointer variable. At last we can go through the last operation, that is deletion of a node from the middle of the list. In the previous sections we already learned about the pointing variables and how is it pointed to the nodes. For the deletion of a node from the middle of the list, there is a slight difference in where to be pointed. On step 4 we can see that repeat step 5 and 6 while pointer 1 data not equals to num. Here num is the actual node which we want to delete. That is, it means that pointer 1 is traversed to the node until data part is not equal to node which we wanted to delete. Step 5 and 6, which you can see that set pointer 1 equal to pointer and set pointer 1 equal to pointer next. It means pointer variable pointed to the next of the pointer 1, that is node which we wanted to delete. On step 7 we can see that set temp equal to pointer. Here, temp is a temporary variable used to storing the pointer value. On step 8, set pointer 1 next equal to pointer next. It implies that disconnect the middle node element in the list by setting the next part of the pointer 1 node with next part of the pointer variable. Then delete the node by free the temporary variable. On this diagram also we can see that there are two pointer variables are exist. This pointer variable is pointed to the actual node which we wanted to delete. This second pointer 1 pointer is pointed to the previous one. Here we can create a new link by setting address part of the pointer variable to this previous pointer 1 variable. The example for the deletion of a node from the middle of the list. We want to delete a node from the middle, that is, delete the node with data part v, so that disconnect the node A with node v by storing the next part of the node v to the previous node, that is A. As a result, node consisting with the data A is pointed to the last node in the list, and delete the middle node by delete the temporary variable. As a result, this previous node is pointed to the last node in the list.